Hi guys, my name is Ajay Yadav and today I am going to present you a video lecture about mensuration. First of all, this mensuration is divided into three main subtypes, which is area, surface area and volume. And this area, surface area and volumes are dependent on different types of geometrical entities. Let's get started with areas. And the geometrical entities which are included in areas are divided as a three-sided entity, which is a triangle, a four-sided entity, which includes quadrilaterals like square, rectangle, rhombus, and the last one is the circle. So let's get started with the very first entity of the area, which is a triangle. So on the figure, on the screen, you can see a figure of triangle ABC. Now, the sum of all the angles of the triangles, when you add each and every angle of the triangle, you get it as equal to 180 degree. And you can see that when you add angle A, angle B, and angle C, you get it equal to 180 degree. And after moving from the angle towards the side, the second most important property of a triangle is that sum of any two sides of a triangle is always greater than the third side. As you can see over here, if you add the length of the side AB plus BC, it will always be greater than the side AC. Now, moving from this sides, we move towards the median and the centroid property. As you can see on your screen, there's a figure of triangle ABC, and from each vertex, that is vertex A, vertex B, and vertex C, a line is drawn towards the opposite side, which intersects at the midpoint of the opposite side. Like on the figure, you can see the line started from the vertex C, meets at the midpoint of AB at the point F. Similarly, B, the midpoint from the angle B, the line from the angle B touches the midpoint of AC at point E. Same goes with the line from A, which touches at the midpoint of the base BC. Now, this lines which joins the vertex and the midpoint of the opposite side are called as medians. Now, each median divides the triangle into two equal areas. Like you can see, ABD, the first triangle formed by the median AD, and the second triangle ADC. These two triangles are equal in area. So it's an important property. The median property is the most important property of a triangle, as most of the direct formulas are being asked regarding the median properties. Now, after median, we move towards the centroid. First of all, what is centroid? Like three medians can be drawn from a triangle as it has three vertex, and the intersection of all these three medians at a point which lies approximately at the center of the triangle is called as centroid. Like you can see on your figure on the screen, G is the point which is a centroid, which is the intersection of all the three medians drawn from the different vertexes. Now, the important property of the median is that it divides the median in the ratio 2:1. Like the centroid G divides the median AD in the ratio 2:1, which means AG, the length of AG is twice the length of GD. Now moving from centroids, we move towards the types of triangle and the important properties related to the triangles. Okay, so you can see on the figure right now that ABC is the bigger triangle in which a smaller triangle DEF is inscribed, and this triangle DEF is formed by joining the midpoints of each and every sides. Like D is the midpoint of AB, E is the midpoint of AC, and F is the midpoint of BC. Now, the triangle which is formed inside the bigger triangle has the area which is equal to 1/4 of the complete triangle ABC. Like you can see, you can directly assume from the figure that this triangle formed at the center using the intersection or the midpoints of each and every side forms in all four triangles inside the bigger triangle. Like ADE is one triangle, DBF is another triangle, EFC is another triangle, and again DFE is the main triangle in the center. Now, the area of any of the triangle formed out of this four triangle is equal to 1/4 of that of the upper or the bigger triangle. Now from this important properties related to area, sides and angles, we move towards the type of the triangles and the important properties. See, if a triangle in the figure, like on the screen you can see in the figure, if a triangle has two sides equal, that is side AB is equal to side AC, or two opposite sides equal and also has two opposite angle equals, this kind of triangles are called as isosceles triangle. Now, for the vertex means the altitude which divides this triangle into two parts, like there is a perpendicular drawn from A towards the base BC, which divides the base into two equal parts, that is BD and DC. The line joining this D and A is called as the height of the triangle, and to measure the area of the triangle, you can directly use the formula half into base into height, which becomes half into, here in your case, the base is BC and the height is AD. It becomes half into BC into AD. Now see, suppose in most of the cases what happens, they don't provide you the altitude thing and they ask you to find the area. So in this case, there is a simple shortcut trick you can apply and get the answer easily, which is that area of the triangle is equal to under root of S into S minus A into S minus B and S minus C. As you can see on your screen, there is a formula written over there. See, let me explain or explore this formula to you, what this formula actually has. S is the semi-perimeter. Okay, what does semi-perimeter means first of all? Semi-perimeter is half of the perimeter, which means half of all the sides. Means when you add the side A plus side B plus side C and divide it by 2, you get the semi-perimeter. Now, let A, B and C be the length of the sides AB, BC and CD. So, if you have the length of the sides with you and also you can find the perimeter with the help of that, you can easily find the area of the triangle. So, the area of the triangle becomes under root of S into S minus A into S minus B into S minus C. Now, from the isosceles triangle, we move towards the equilateral triangle. Okay, the main difference between the isosceles triangle and equilateral triangle is that isosceles triangle has a pair of same sides, like only two sides are same in length, while in the case of equilateral triangle, all the three sides are of same length. And we can see the area of the triangle of the equilateral triangle is given by under root 3 by 4 into side square. So in the case whenever an equilateral triangle comes, you don't need to find half base into height. Directly apply the formula under root 3 by 4 side square and you will get the area of the equilateral triangle. So see, from equilateral triangle, mostly the question asks are either based on a circle inscribed inside an equilateral triangle or an equilateral triangle inscribed inside a circle. So let's get started with the first type. The figure 1, which you can see on your screen, shows that there is an equilateral triangle ABC. Each side A, like each and every side is equal. That's why it's an equilateral triangle. Now a circle is inscribed inside this equilateral triangle. Now to find the radius of that circle, see, you need to find, like the question comes, you need to find the radius, the circumference or the area of the circles inscribed inside the equilateral triangle. So the first thing, even if you have to find the circumference or the area, is to know the value of radius. So you can directly apply the formula that radius of a circle inscribed inside a equilateral triangle is equal to A divided by 2 root 3. While in the case of equilateral triangle inscribed inside a circle, like you can see in the figure number 2 below, that an equilateral triangle is inscribed inside a circle. Okay, here again, if you need to find the circumference, area or various other properties of the circle, you need to first of all find the radius. Now here in the case when an equilateral triangle is inscribed inside a circle, you can directly use the formula that radius is equal to A divided by root 3. Now from the circles, which we move towards the second important entity in the area, which are quadrilaterals. Okay, first of all, what are quadrilaterals? Quadrilaterals are four-sided figures like square, parallelogram, rhombus, rectangle and many others. So let's get started with the most common geometrical entity of four-sided figure, that's a square. So on your screen you can see a figure of ABCD, which is in square, which is a square. And now the properties of square are that each sides of the square are equal and each sides of the square are perpendicular to each other. Like you can see, the side AC is equal to side BC, while side BC is equal to side BD, and similarly side BD is equal to side AD, and all the four sides are perpendicular to each other. See, this is the basic property of the square, but the questions are generally asked in regards to the diagonals of the square. So let's get started with the properties of the diagonal. Like on the figure you can see, there is a diagonal AB and DC. They both intersect at the point O. Now the length AO is equal to OB. Similarly, the length DO is equal to OC. And intersection, at the point of intersection of the two diagonals, they are at 90 degree, which means they are perpendicular to each other. Also, to find the area of the square, there is a simple formula which is side square. Means you can take any side, the length of the any side, and square it. You will get directly the value of the square of the square of the area of the square. Now, moving towards the perimeter of the square. First of all, what is perimeter? As in the previous slide, we have explained that perimeter is equal to sum of all the sides. Now here, the perimeter becomes sum of all the four sides, which means length of AC plus length of CB plus length of BD plus length of DA. Okay. So from square, let's move towards the second important geometrical entity, which is rectangle. Okay, on this first figure on your screen, you can see there is an entity having sides AB, BD, DC, and AC. So the important property of rectangle is that the opposite pair of the sides are parallel to each other as well as equal. Like AB is parallel to CD and they both are equal. Similarly, AC is parallel to BD and they both are equal. While AC and BD are called as length of the rectangle, while AB and and CD are called as the breadth of the rectangle. Okay, let's postulate the formula for finding the area as well as the perimeter of the rectangle. Area of the rectangle is as simple as that, which is length into breadth, length into breadth. Now, you can see on your figure, when you multiply length by breadth, you will get the area of the rectangle. Now, for the perimeter, again, it becomes sum of all the sides. So let's add all the sides over here, which becomes length 1 plus breadth 1 plus length 2 plus breadth 2, which means L plus B plus L plus B, which makes 2 in bracket L plus B, means 2 to the whole of L plus B. Now, from rectangle, we move towards the parallelogram. The second figure on the screen, you can see, first of all, the main difference between a rectangle and parallelogram is that they have the sides parallel, but the sides are not equal over here. Like you can see, AC and BD are parallel to each other. Similarly, AB and CD are parallel to each other, but they are not equal in length. Okay, now moving towards the area of the parallelogram. It's very simple. It directly becomes base into height. Base in the figure, in this case, the base is BD. And to find the height, we draw a perpendicular from A towards the base BD, which intersects the BD at the point O. So AO here acts as the height of the parallelogram, while BD acts as the base. So if you need to find the area of the parallelogram, it's very simple. Just multiply the height, which is AO in this case, to the base, which is BD in this case. Now from parallelogram, we move towards the next important entities in finding the areas under the quadrilateral section, which is rhombus. Now rhombus is same as that of square. The sides, all the sides are equal, like AB is equal to BD, which is equal to DC, and which is equal to AC, as you can see on the first figure on the screen. Now, directly to remember the thing about rhombus is that the area of the rhombus is equal to half into product of their diagonals. Like in this case, AD and BC are the diagonals of the rhombus. So if you need to find the area of the rhombus, directly multiply the diagonals, both the diagonals, and divide it by 2. So you directly get the area of the rhombus. Now the second, the last most important property in the trapezium, like in the quadrilateral section, goes with trapezium. Most of the cases or most of the numericals are generally asked regarding trapezium, as most of them can get confused regarding with parallelogram or rectangle. See, in trapezium there is only one pair of parallel sides, like you can see on the figure, below figure, the second figure on your screen. The side AB is parallel to CD, okay, while the side AC and BD are not parallel to each other, which means they have only one pair of parallel sides. Now, to find the area of trapezium, it's again equal to half into the sum of the parallel sides as well as the perpendicular distance between them. Like again in this case, as we have done in the case of parallelogram, to find the perpendicular distance between the two parallel sides, we draw a perpendicular from the upper side toward the lower side, and we get it, as you can see on the figure, AO. AO acts as the perpendicular distance between the two parallel sides. And when you need to find the area of the trapezium, it's very simple, half into the sum of the parallel sides into the perpendicular distance between them. And like in the cases, the perpendicular distance can be easily found out by applying Pythagoras theorem. You can easily get the value of AO over there, which is the perpendicular distance. Now from trapezium, we move towards the, like this was the last part in the quadrilateral section under area. Now we move towards the third most important entity under the area part, which is the circle. So first of all, what is circle? Circle is the locus of all the points which are equidistant from the center, like the boundary, or you can say the boundary of the circle. All the points lying on the boundary of the circle, or the points which are equidistant from the center, makes the boundary of the circle. Okay, let's get started. See, the most important part is that a line joining the center and any point towards the boundary is called as radius. Now we need to find the formulas for circumference, the formulas for area. Okay, these are the two basic properties, area and circumference. Now the area is equal to pi r square, while the circumference of a circle is equal to 2 pi r. Now these are the most general properties of circle. We need to learn more about the length of the arc and the area of the sector, which is an important topic under circle. So like on the first figure you can see on the screen, the length of the arc, which means the arc which is going from A to B. There is a certain section over there, and you need to find the length of the arc. It's very simple. The formula is that it is equal to circumference into theta by 360. First of all, what is theta? Theta is the angle between the two lines joining the two endpoints of the arc. Like in this case, the arc is AB. So theta should be the angle between the center, between the two lines, the first line which goes from center and joins the point A, while the second line which goes from center and joins the point B. Now this angle theta divided by 360 to get it the value in radians, multiplied by the circumference, which is 2 pi r, you get the length of the arc. So length of the arc formula can be easily formulated as 2 pi r into theta by 360. And same to find the area of the sector. Okay, area of the sector means, like in the figure you can see, if we assume the center of the circle is O, then the area of the sector AOB, the complete area, the content in that part AOB, can be easily formulated using the formula area pi r into theta by 360. Means pi r into theta by 360 directly gives to the area of the sector. Now from circle we move towards the semicircle part. See, half of a circle is a semicircle. Similarly, all the properties over here like area, circumference becomes half in this case. The area of the semicircle becomes pi r square divided by 2, which means area of the circle divided by 2. Now same in the case of circumference of the semicircle goes 2 pi r divided by 2, which makes it pi r at the end. Now from this end of this area section, we move towards the volume and the surface area part of our slides. Now, first of all, before starting with, we need to clear what is surface area and what is volume. Now, the first thing which we get confused regarding is that what is the main difference between surface area and the area part? So, see, area and surface area. The surface area constitutes of sum of all the areas. Okay, for example, let's just you imagine the LPG cylinder you have at your house. Now, that LPG cylinder is divided into three main areas. One is the curved surface area, the rolled part. Second, there are two circular areas at the end. One there is at the base and one there is at the top where you handle it. Now, to find the surface area of that complete LPG cylinder, you need to have you need to add the three main areas. First is the curved surface area. Second, there is the area of the upper circle, and third is the area of the lower circle. So the basic difference between area and surface area is that in the case of surface area, you need to add each and every part of that area. Now the second part is the volume. So let's get started with the volume thing. See, volume is the actual content of any body. Okay, in this cases, usually a 3D space is taken into consideration to find the volume. Okay, let me just relate you how 2D area is related to a 3D volume. Okay, if a rectangle in a 2D space is being proposed in a 3D space, it gets converted into cuboid. Like you can see the first entity we have on a screen, which is a cuboid. It's nothing but it's a normal rectangle proposed in an 3D space. See, you can see it's related to the same diagram over there. You can see a first face of the rectangle in the front, then there is on the back. That means it is completely 3D structure of a rectangle. Now, for the cuboid, let's suppose L be the length of the cuboid, B be the breadth of the cuboid, and H be the height of the cuboid. So the volume of the cuboid can be easily taken by the formula length into breadth into height, which means the multiplication of all the three sides of the cuboid. Now, the surface area. The surface area of the cuboid is again related to the area of the rectangle. Here, the surface area of the cuboid becomes 2 in bracket. L into B means the first two sides, then plus B into H, the second and the third side, plus H into L, the third and the first side. So you can easily remember, can easily make a formula related to that. So the surface area here becomes 2 into L into B plus B into H plus L into H. Now to find the length of the diagonal, see that's an important property for cuboid. In the case you need to find the length of the diagonal which joins the two edges of the cuboid, you can directly use the formula that length of the cuboid is equal to under root of L square plus B square plus H square. Like you can see on your screen, you have the formula for the diagonal. The length of the diagonal here is equal to under root of L square plus B square plus H square. Now from the first 3D entity, we move towards the second 3D entity, which is a cube over here. Now you can see on your figure, the second figure on the screen, it represents a cube. So you can relate it when a 2D diagram square is proposed in a 3D space, it becomes cube. Now here you can directly see from the figure also, you can relate the things. Now to make it more easy, we will relate the formulas as well for the cube and the square. So let's get by this way, like let each edge of the cube be of length A, means let each side of the cube be equal to A. Now similarly, the volume of the cube is equal to A cube, means cube of any of the side gives you the volume of the cube. Now the surface area. See, in the case of the square, the area was A square. In the case of the square, you remember in the previous slide, we took it as the area of the square is equal to A square. Now, when you represent N square from a 3D face to from a 2D face to a 3D face, which converts it into cube, it has 6 faces. So the complete surface area here becomes the sum of all the A square, which makes it 6A square. Now, the most important property is that the diagonal. The diagonal of the cube is equal to root 3 into A. Means when you multiply root 3 with any length of the cube, you get the length of its diagonal. Okay, from the cube, we move towards the next geometrical entity, which is in cylinder. Okay, again, as I have explained in the starting, the cylinder, relate this cylinder to the LPG cylinder you have at your house. Okay, just go with the basic. First of all, we will take the basic nomenclature for this, that let r be the inner radius, small r, let capital R be the outer radius. Okay, let h be the height of the complete section, as well as along we will find the various other things. Like see, the cylinder, suppose this cylinder is kept vertical over here, horizontal over here. Now the length, you can see the length is the distance between the two circular part. As you can also see on the screen, the two circular end position 1 and end position 2, the distance between this two is represented in the point in the way of height or the length. Now to find the volume, it's very simple. It's pi r square h, means pi multiplied by square of the radius into the height, or you can say height is the length as well, which is the distance between the two end points of the cylinder. Now the second most important part in this, to how to find the surface area. So as I have explained earlier, that this surface area for a cylinder constitutes of three main subparts. One is the curved surface part, which goes between these two circles, as well as the two other parts are of the respective circle, one at the starting end and one at the end ends. So just we can formulate that the total surface area of the cylinder is equal to curved surface area plus area of the upper circle plus area of the lower circle. Okay, so let's the curved surface area of the cylinder is 2 pi rh, plus the area of the lower circle becomes pi r square h, plus the area of the upper circle becomes again pi rh. So pi r square, when we add this thing, it becomes pi r square plus 2 pi rh plus pi r square, which gives you 2 pi r square plus 2 pi rh. So means it's the total summation of all the areas, which includes two areas of the circle and one areas of the curve and one area of the curved surface plane of the cylinder. Okay, now moving towards the second last entity, 3D entity which we have with us in the case of surface area and volume is the cone. You can see on your screen, when a triangle in 2D is expressed in the form of 3D space, it gets converted into cone, like you can see on the figure. You can easily read the formulas as well. Now just look for the terminologies related to the cone over here. Let L the slant height. Let L be the slant height. The slant height you can see on the screen. Just the slant height, as well as let H be the main height, which is the perpendicular distance between the base to the upper vertex, and the distance between it, let be that with the radius at the base. Now you can see that the volume of the cone is very simple, which is 1 by 3 pi r square h, which becomes the 1/3 of that of the cylinder. You can relate it that way as well, that the volume of the cone is 1/3 of that of the cylinder. Now we move towards the total surface area. Now the total surface area here in the case of the cone, it becomes the curved surface, upper curved surface area plus the base, which is a circular area over here. So the upper surface area, the area of the upper surface area becomes pi rl, while in the base it becomes pi r square. So the total surface area of the cone is equal to pi rl plus pi r square, out of which the first pi rl goes with the curved surface area, the upper curved surface area, as well as the pi r square goes with the circular part, which is at the base. So from the cone we move towards the last geometrical entity, which is sphere. See, all the entities, all the geometrical entities, the formulae which are mentioned in this video lecture are quite important. If you remember those things, you can easily solve any topic related to measuration. Okay, so let's get started with sphere over here. First of all, what is sphere? When a circle is expressed in the form of 3D space, it gets converted into sphere. You can imagine by that way easily by seeing the figure that it is completely perfectly round body. Circle gets perfectly round in the space, in the 3D space. So let R be the radius as shown in the figure, the upper figure on your screen. So the volume of that can be given by 4 by 3 pi r cube, and similarly the surface area can be given by 4 pi r square. Now see, it has only one surface area, which is perfectly round area, so no curved surface area addition or no any other area addition takes place in the case of the sphere. So directly you can write that area of the sphere, or the surface area of the sphere, is equal to pi r square. Now hemisphere. What is hemisphere? A half of a sphere is called as hemisphere, same as in the way we have related the semicircle and the circle in the area section. We relate sphere and the hemisphere in this volume and the surface area section. So half of a sphere is called as hemisphere. Similarly, the properties like volume and the various other properties go half over here. Like you can directly get the volume is equal to half of that of the sphere, which becomes like for the sphere it was 4 by 3 pi r cube. The volume for the hemisphere is going to be 2 by 3 pi r cube. Now in this case you can see, to find the total surface area, we need to add the curved surface area, the upper curved surface area, as well as the base, which is circular area over here. So the upper circular area, the area of the upper curved surface is 2 pi r square, like you can see on your screen, and thus the total surface area becomes 3 pi r square. So this 3 pi r square has came by the addition of 2 pi r square plus the base, which is pi r square. So the area or the total surface area of this hemisphere becomes 3 pi r square.